Hello, good afternoon. Today we're going to see the concept of classes, objects, and methods in the object-oriented programming. So we'll start with the first one, that is classes. So class is actually not a real world entity. It is just a template or blueprint or a prototype, a sort of first system from which objects are created for that particular class. Now, one again important point with respect to the class is that class does not occupy the memory. Then class is a group of variables of different types and a group of methods. And this particular class contains data members, method, constructor, and the nested class. So whenever we are talking about this particular class, so it is a user defined data type which consists of multiple variables and multiple functions. So class decide what features an object should have. Class may represent a real-life entity or purely a software entity. The variables can be of any type supported by, now here we are talking Java, and are called as the data members of that particular class. Methods are commonly defined to work with the data members of the class. The method belonging to a class are called as member methods, right? And data members are commonly kept hidden. That is what expected in any object-oriented programming language, and that is the concept in object-oriented programming. Member methods operate on data members. So also the methods are means of message passing between different objects in software system. Right? So here you just see a class declaration like access modifier, the class keyword, and the name of the class. And here data member method, you can have a constructor and you can have nested class for that particular class. So these are nothing but the composition of any class. So and you can say this is sort of syntax for defining the class. So what are different components with respect to, say, here we're talking about the Java. So with respect to Java class, what are different components, that also will say. So in general, class declaration can include components like modifiers, class keyword, class name, right? Then superclass if any, interfaces, and the body of that particular class, right? So these things are expected in any class. So modifiers, a class can be a public or has a default access modifier. Class keyword is required to create a class. Then a particular class name with convention. Then superclasses if any, that means the name of the class or you can say the parent class, superclass if any. Again, this particular point concept of superclass exists in case of interface, inheritance, concept of inheritance with respect to the or by using the keyword extend. Then interface. In case of pure abstract classes, this particular interface concept can be used, and you can have a class body that is surrounded by the this particular process. So this is nothing but the components of general, you can say that Java class. Then we have a, you can say that example of the class, a class student. Here you are having integer ID, that is the data member. That is also called as, you can say that, instance variables. Right? These are also called as the instance variables. Then string name, that is again an instance variable data member. Then main function we are writing, where we are creating an object of that particular class student. So S1 is the object of class student that we are creating using the new keyword and the class name, and we are printing the ID and the name of that particular student with respect to the object of that particular class. Yes, as we are not having any, we will not assign any information to ID and the name, so it will be 0 and none accordingly for that particular operation. Now, next important point, what is object, right? So object is one of the important concept in this particular case. So object is nothing but, in short, it is nothing but an instance of that particular class. So object is a variable of type class. We can also say like this. Object actually holds the data and the methods, that is function to operate on the data. So thus the objects are used in a program to use feature or different features defined in that particular class. So object occupy memory space according to members of a class. So memory is not allocated for the classes that already there, but object can occupy the memory. So object can communicate with each other using what are the methods specified inside that particular class for which you are creating the object, right? So we can have a small example. If my animal is my class, then we can say lion is my object with respect to this class. If I have vehicle as my class, car is nothing but object with respect to that particular class. You can have another example here. Say public class name is nothing but a class. You are assigning some value file to the integer x, that x variable. You are creating the object, that my object of the class name, and you are printing my object dot x. So it is going to print 5 for that particular class, for that particular variable x. Now let's quickly have a differentiating factor between the class and the object. So class is blueprint or template from which objects are created, whereas object is an instance of a class. The next class is logical entity, whereas object is a physical entity. Class does not allocate memory space when it is created. Object allocates memory space whenever they are created. Then you can declare class only once. You can create more than one object using a class. That means for the same class, you can have multiple objects. For student, you can have Ravi, Amol, Anil. So these are nothing but different objects for the student class. So class is declared using the class keyword. That is class, this is the keyword and the name of the class. For example, class and the student. Object is created as class name and object name. So student S1. So S1 is the object of class student that we are specifying here. Then a class is used to bind data as well as methods together as a single unit, whereas objects act like a variable of that particular class. Again, you can have another example of class as a fruit, and objects of that particular fruit class are apple, banana, mango, guava, etc. Okay. Then next important point that we are supposed to see the concept of access modifiers in Java. Concept of access modifiers in Java. So in normal terms, say encapsulation defined as the wrapping of your data and information under a single image, right? So in object-oriented programming, encapsulation is defined as binding together the data and the methods that manipulate them accordingly. So whenever we are talking about this particular concept of access modifiers in Java, so they help to restrict some scope of a class, variables, methods, or data number. So it provides security, accessibility. Again, you can see encapsulation sort of thing. Different concepts which are there in the object-oriented programming. They are also supported through these particular access modifiers in object-oriented programming, or to be specific with respect to Java in our case. So we'll see how Java access modifiers, their types and uses of access modifiers in this particular case. So types of access modifiers are like default, private, protected, and the public access modifier. So default access modifier, that is no keyword default, private, you have to write there, protected, and the public. So these are nothing but four type of access modifiers present in Java: private, default, protected, and the public. So one by one we'll see what is this all you can say default, public, private, and protected. The default access modifier. So when no access modifier is specified for a class, or method, or a data member, so you have to consider that it is having the default access modifier, and that is again by default. The data members, classes, or methods that are not declared using any access modifiers, that is, that are not having default access modifier, are accessible only within the same package. So we'll see one example here. We'll get two packages and classes in the packages. We'll be having the default access modifiers, and we'll try to access a class from one package from a class of second package. Now here you can say that package P1 is there and this is package P2. They are having program one that we are writing for this particular one. So class, you can having class break. So this program is for using we're going to use a default modifier. So class break, where we are having void display, we are printing something. And here we are having the another program 2 that is inside the package P2. And this package P2 is going to import the package P1. Again, this class is having this program to have default access modifier. So class means class Greek new, and inside this particular class we are writing main function. And what we are doing here, we are creating the object of this particular Greek class, that obj, which is present inside a package P1, which you are imported in the package P2. And through this particular object class of this particular Greek class, we are trying to access the display method. We are trying to access the display method of this particular gift card from the package of the another one. So it will, when you come to compile this, it will going to be the compile time error because default access modifiers are specified. Then next we are going to see the private access modifiers. Before that, default access modifier when you're talking about, so default access modifier, whatever the variables methods which are comes under default access modifier, they're accessible from the same class and the same package, right? Then next we'll see the private access modifiers. Concept of private access modifier. The private access modifier is specified using the keyword private. Whatever the method, data members declared as a private are accessible only within the class in which they are declared. So whatever the scope of that particular class, inside the, you can see that particular program only to the inside that class only the access is provided. So any other class of the same package will not be able to access these members. Remember that private access, whatever the members we can say that declared as private are not accessible to another classes of the same package. So top level classes or interfaces cannot be declared as private because private means only visible within the inclusive class and protected means only visible within the inclusive classes and any subclasses. So hence this modifiers in terms of application to classes apply only to the nested classes, not on the top level classes. So we're going to see here the example where we're going to create two classes, class A and the class B, class A and the class B within the same package P1. And we're going to declare a method in class A as a private. That means class A method display is a private method, and we'll try to access this particular display method from the class B, right? So package P1, we are having class A, we are declaring display method as a private. Then we are having class B. Inside class B, we are writing the main method, and what we are doing here, we are creating the object of class A. That is A obj is equal to A. This is going to create object obj of class A, and through this particular object obj, we are going to access the method of the private method of the class A. So obj.display, when you are writing this, it will not going to give access to the display method of the class A from the class B. So that is nothing but the private access modifiers. That means you will not have access. You will get error here in this particular. Then next, protected access modifier. Now protected access modifier means whatever the, you can say that variables or methods you declare the protected through inheritance, a single inheritance, they are accessible to the immediate child class. So protected access modifier is specified using the keyword protected. Now the methods or data members declared as protected are accessible within the same package or subclasses in different packages. So we'll create two packages here, package P1 and the package P2. Then class A in package P1 is made public to access it in the package P2. The method displaying class A, that is this display method in class A, is protected, and class B is inherited from class A. So we're going to inherit class B from class A. So that's why extend keywords comes into the picture. It's a single inheritance where class B is extended from class A, and this this particular protected method is then accessed by using, we are going to access by creating an object of the class B. So just look here, class B extend class A, and inside main we are creating the object of class B at obj is equal to new B. So obj is the object of class B. In the class B we are not having any display method, but as class B is extended from A, and the method is the display is protected, so it should be initiated up to one level. That means class B can access this particular display method. So when you are executing obj.display, so it will going to execute the display from method of this particular class A, which is the protected, and you will get this particular output. This is the protected access modifier. The next, public access modifier. Now public access modifier is specified in the keyword public. Here the public access modifier has, you can say that, big scope among all the access modifiers. Classes, methods, data members that are declared as public are accessible from everywhere in that particular program. So there is no as such restriction of the scope of the public data member. Just see here program 1 and program 2. So here in program 1, that is inside the package public class A, and method display is also public. Here in another program we are having class B, and again inside that particular class B method, class B. we are writing the main method, and here we are creating the object of this particular class A obj is equal to main A, and we are going to um, display or execute this particular display method from the class A. As it is public, so you can execute the display method of the class A from the class B. You get this particular output. So this is nothing but the, you can say, access modifiers in the object-oriented programming. Then next, passing and returning objects in Java. Passing and returning objects in Java. So when you are dealing with this particular passing and returning objects in Java, so method comes into the picture. Now here a method is group of statements that together perform a specific task. So every Java program has at least one method which is main, and almost all you can say trivial programs can define additional methods. A method can access object type parameter, or it can return object as a return method. So while defining and declaring a method, we have mentioned parameter type, uh, and you can say return type as a class whose objects we are supposed to use. With respect to Java, it is having a standard library which provides numerous built-in methods that program can call. For example, method is a concat to concatenate two strings. Method compare to compare two strings, which are lexicographically, and many more. You can say methods in a string library of Java you can use accordingly. So when we are talking about this passing and returning objects, your method, that is the important part where it should have a return type, method name, parameters, and the method body. Right? So when we are dealing with this particular passing and returning objects, so while creating a variable of a class type, you only create a reference to an object, right? Then when we pass this reference to a method, the parameter that receives it will refer to the same object as that referred to by the argument. Right. So this effectively means that objects act if it are passed to the method by use or by reference. Changes to the object inside the method do reflect the object with as an argument. Now let's just have a quick look at this particular example where you are having a class object pass demo having two variables, and this object pass demo. This is method. Now in this particular case, this method is called as a constructor because name of this method is same as the name of the class. Then we are having another method boolean equal to, where you are passing object as a parameter. Object pass demo, which is a class name, and this O is nothing but the object for this particular class. Now it will return true if this particular object is equal to invoking object notice on object is passed as an argument to the method. So this particular operation will get performed. Now come to the another class, a GFG. That class is there, where we are writing the main method, and here we are creating object OB1, object OB2, and object OB3 of this particular object pass demo. First obj1 object we have created using this statement with 122 with two parameters. So it is going to execute this constructor, parameterized constructor it will going to execute. Then next it will going to execute the same constructor with these two parameters, and for the object obj3 it will going to execute the parameter constructor with these two parameters. Now next important point is that whenever we are writing the system.out.println and ob1 equal to ob2, that means we are comparing two objects. So plus ob1 dot equal to ob2. So it will going to pass this ob2 as a, you can say, parameter, passing the parameter object as a parameter here, and it will going to execute this body, right? So whenever we are dealing with this particular point, so it will return true, right? Because both are, you can say that 122 for OB1, 122 for OB2, both are same. But when we are going to execute OB1 dot equal to OB3, so what is OB3? That is value assigned to the constructor -1 and -2. So this statement will not holds true. It is fast. So it is going to return fast. So in this particular case, you can say passing object, passing to a method we can extend. A returning object, you can see you are having class object return demo, some integer variable, object return demo as a constructor with single parameter. Then object return demo increment by 10, that particular function or method you are defining. Then you are having another class at GFG where you are writing main. What we are doing here, object return demo, that means for this particular object return demo, we are creating object 1 with this statement for the parameter constructor. So A will become 2. When object return demo OB2, we are creating OB2, that is nothing but the OB2. Then when you are writing OB2 is equal to OB1 dot increment by 10, so in this particular case, it is going to increment all this particular function. Already a value is 2, so it will become a value is 2 in this particular case. When you are writing OB1 dot a, so this OB1 dot a is nothing but 2. So it is supposed to print the 2, but whenever I am writing ob2 dot a, so it is going to print 2 plus 10 12, right? So in this particular fashion, because through this particular 10 or initially ob1 dot a, it will going to return the 2 to you to this particular return time, but whenever you are writing this uh, OB2 dot a, because through OB2 only you are calling this particular function. But for OB1 you are not called, so OB1 a value remains same. For OB2, and I executed this, a is already 2, it will become 2. For OB1 it will print 2, and for OB2 it will going to print 12. And it will return that particular object to this particular temporal object temp. Now the array of object. The array of object, the name itself suggests that it stores an array of objects, unlike the traditional array it stores values like string, integer, boolean. Right. Now, an array of object is created using the object class. So here class name, object array reference. Alternatively, you can also create using class name, object array reference using this square bracket. Another you can say that more thoroughly you can to say student in my class, and this is my object. In this particular fashion you can create array of object, or using student object, and this syntax you can create the array of object. So this is not a good example how you can create, and this particular figure shows the structure of array of objects. So for example, bike is my class, B is nothing but my array of object is equal to new bike 9. So it is going to store 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces for this particular array of object for the object B. Where this is points to B of 0, that is object B of 0 is the object, then serial number and the model name. That what is the specimen for that particular switch, this is serial number and model name. So these are the attributes for that. And this is using the parameters constructor you can create. Now how to initialize array of object? By using the constructor you can initialize it. By using the separate number method you can initialize it. Just see here, you are having class GFG inside which you are writing main. A student array you are declaring for this particular class student. The public is the ID, public string name. Some user defined method is there. Another user defined method is there. Inside GFG class we are having main function. Then student, for this particular student class we are creating the array. ARR. So ARR is equal to new student 2. So allocating memory for two objects of type student. So that is done by this particular statement. Then creating actual student object like ARR 0 is equal to new student and ARR 1 is equal to new student. So two different objects, heap memory will get allocated for this particular two different objects. Now we are assigning data to the students. So using constructors, we are initializing the array. So say, so using these two user defined functions, we are initializing this. So some values we are passing to set data. So the set data will get executed accordingly. So this dot id is equal to id, we are using this keyword because name of the instance variables and these variables same. That's why we are supposed to use this. So in this particular fashion, you can initialize the array. Then this is the output with respect to that program. Now next important point that we are supposed to see, that is nothing but the concept of encapsulation. So encapsulation in Java, it is the process of wrapping code and data together into a single unit. Right? Now, for example, here capsule, which is a mix of several medicines, so that is nothing but you can say that best visualization of the concept of encapsulation. Now, we can create fully encapsulated class in Java by making all the data members of the class as private. That is fully encapsulation. So only object of that particular class can access it. So Java means class is the example of fully encapsulated class. What are the advantages of encapsulation in Java? By providing only a setter or getter method, you can make the class read only or write only. So in other words, you can skip the getter or setter method. Next, it provides you the control over the data. Suppose you want to set the values of ID, which should be greater than say 100 only. So you can write the logic inside the setter method. So you can write the logic not to store the negative numbers in the setter method. Again, it is the advantage of encapsulation is that to achieve data hiding in Java, because class will not able to access the data through the private data members. The encapsulate class is easy to test, so it is better for the unit testing. Let's see the example here. Java class which is fully encapsulated class. Fully encapsulated means you are supposed to use the access specifier as the private. So you are having public class student private name. You are having get name method, and that setter method you are using here. Then you are having another class test where you are writing main method. You are creating the object of this particular class student as S. Through this S only you can access the set name method and the get name method. Then another example of Java encapsulation you can see here, class area. You are supposed to put a field to calculate the area, so you are adding integer length branch. So you are using the constructor because name of this method is same as the name of the class. Some code you are writing here to calculate the area, and get area code you are writing, that is the user defined method to calculate the area. Inside the class main, you are writing public static void, and here area rectangle is a new area. So 5 and 6 these parameters you are passed to the parameters constructor, and then you are calculating the area for this. So you will get some output as 30 here. In the particular example, we have created a class named area. The main purpose of this class is to calculate the area. Now to calculate an area, we need two variables like length and width, right? And get area, and we can set here such type of methods we require. So here the field and methods can be accessed from other classes as well. So and this is not we can say that data adding concept. Now this is only encapsulation. We are just keeping similar code together to explain this particular concept of encapsulation. So why encapsulation? In Java, encapsulation helps us to keep related fields and methods together, which make our code cleaner and easy to read. Now it helps to control the values of our data fields. For example, a class person is there and you are having age that attribute as a private, and you are having say public void set age in age, and you are having some age, you can say that greater than is equal to 0, then you are assigning the age. Now here we are making the age variable as private and applying logic inside this particular set age, right? And here now you can say that the age cannot be negative, right? Whereas it is greater than equal to 0, but it should not be negative. So you are imparting a better control, right? And data hiding concept is also you are imparting here. So the getter and setter method provides read only and write only access to this particular classes. Now data hiding again in detail is a way of restricting the access of our data members by hiding the implementation details. So encapsulation also provides a way of data hiding. We can use access modifiers to achieve the data hiding. As I told you that you can use the age as a variable as a private one, and then through the object of the same class you can access that particular variable. Then that is nothing but strictly you are adhering to the concept of data hiding. Then we're supposed to see the concept of Java methods. Now method, you know, that is a block of code which only runs when it is called. So you can pass data known as parameters into the methods. So methods are used to perform certain actions and they are also known as the functions. So just see the syntax for the methods in the Java. Access modifiers you are supposed to specify return type, method name, list of parameters. So access modifier public, private, whatever. There are four we have specified. Then return types, integer, so on. Name of the method and list of parameters if any. And here you are supposed to press the body. What is the advantages of method? You can go for the code reusability, code optimization using this particular method. Then method declaration. This when you are talking about this method declaration, you are supposed to use the modifiers. So four modifiers like public, protected, private, default. You can specify. Return type, the data type of the value written by the method or void does not return a value. It is mandatory in that particular syntax. Method name is required appropriate with respect to the program and the context. Parameter list, that is it is optional in syntax. The exception list you can also provide in bracket block, that is also optional. And actual method what you can specify. So you can say that actual example you can see here. This public is the modifier, integer is the return type, max is the method name, index into IDs are the parameter list, and this is the body of the method. Right. Now there are types of methods in Java: predefined methods and user-defined methods. These are two types of methods in the Java. In Java, you can say predefined methods are the methods that is already defined in the Java class libraries, and it is known as predefined methods. Okay. So it is also known as the standard library methods or built-in methods. When you are writing the system.out or content and so on, and any methods which is built-in, that is predefined. User-defined method means based on the program and need. User can use their own name to the method, that is called as the user-defined method. There are two ways to create a method in Java. First, instance method. So access the instance data using object name declared inside a class. Syntax is this. And for static method, access the static data using the class name, not the object name. That is declared inside the class is static keyword. So this is the syntax for it. Just see method illustration in the Java. See class addition is there. Inside this class addition, some variable some you are giving. Public int add to it. This user defined method with two parameters we are specifying. Another class here which is there where we are writing name. Add, that is the object of this addition class we are creating, and we are saying int s is equal to add a dot add to int with these two parameters. So this add dot add to int will going to call this particular method. It will return the addition of a and b inside a sum to this particular s, and then you are printing that particular s. So this is nothing but how you can access the method in the Java. Now create a method in the Java. You can say that uh, you can give a method name appropriately. If you are using static keyword, it means that the method belongs to the main class and not an object of the main class. Right? Then void means that this method does not have return value. This column method, just see class main is there, and here static void my method. So my method is the static method, and in main what you are doing, just you are writing the name of the method my method. So no need of object to call that particular static method. Directly using the name of that particular method you can call it. Then return values for the method. So for example, this is the class main, this is static in my method. You are writing addition of this. When you're calling this particular my method with this parameter, it will going to return you 8. So that is nothing but how you will get the return value from the method. So that's all for the today's session. Thank you.